Hey, my name is Ben and I teach you how to write Unity shaders from scratch. Do apologize, it's been a while since I last put out a video, but I'm going to be more committed to doing this. I do want to get videos out once a week at least. So this is the one I've put together for you guys. It's using URP and done in Unity 2022. I have been seeing comments that, hey, people are moving forward to the next version of Unity, so I want to try to do my best to keep up with the versions of Unity. This is using a lot of Unity's built-in stuff, such as their emission, but I'm showing you how we can calculate the searing effects that I've shown you before on to even within URP. So this is a metallic shader that is all the math is done within URP, but you can still have a burning effect. So let's jump right into the video. All right, so as you can see here on the right, we have a very basic shader. All it has is a main texture input and a base color. As you can see, the effect is this texture, and here is the color that currently is applied as a tint. If you don't know how this base shader in URP works, I encourage you to check out one of my other videos. I'll link it in the description below. So as you can see here, all it does is it spits out an albedo color. We're adding it to our surface data, and we are using Unity's version of URP, physically based rendering, as an input data and surface data, and we are just displaying it on screen. One thing to note, this is also happening in Unity version 2022.3.4. So the first thing we're going to do is we're going to add back our smoothness and our metallic, and we're going to add it to the metallic here and the smoothness, which is here. So let's go ahead and do that. This is our smoothness. We're going to do a range of 0 to 1, and this will be our metallic. I'm going to put all our float ones here, so smoothness and metallic. We can then go ahead and use smoothness here, metallic here. Let's save that off. As you can see right now, smoothness works, metallic works as well. It is having this issue where funny effect on the facets of our sphere. To fix that is simply we need to normalize our normals. So is it I? Yeah, it's I. And that will resolve that one. That's a pretty simple fix. All right, so the next thing we want to do is create a burn area and an unburnt area. We also need a bit of a cutoff to try to differentiate between the two areas. So let's go ahead and create a burn cutoff. As you can see, I've already had it here. Next, in order to create the burn cutoff area, what we want to do is have a float. Let's call it an unburnt area. Unburn area, sure. And what we need to do is do a step function. And we'll use the color of the texture, main texture, the red. What we're going to do is have the red burn first. So we'll step it against the burn cutoff. And we'll multiply this here, and we should see it burn this way. As you can see, it's actually inverted. Seems like if we drag it this way, you can see how the red seems to burn first, or go to black first, and then the green, right? It's a little bit easier to see in the scene camera. So let's go ahead and invert the burn cutoff. That should flip it so that when burn cutoff is 0, as it goes further higher, it will start burning in the red or going to black. That way, what is currently being displayed is considered the unburnt area, and the burnt area would be this, but 1 minus. In fact, we can just 1 minus the unburnt area, showing the red as the burnt area. All right, so the next thing I want to do is start to have a burnt area and a base color. We aren't really going to use this texture as a way to display. So what we actually have is, without the color here, we should be showing just the base color here, currently set to white. We can maybe set it to something like green for now. What we need next is the burnt color. So let's go ahead and duplicate the base color, and we'll call it burnt color. This one will be called base color. We'll go ahead and add this here so we can use the burnt color. And instead of multiplying it, what we're going to do is we're going to lerp it. We're going to lerp the base color to the burnt color and probably do it by the unburnt area. So we'll do the burnt color to be, let's say, we'll do red. It's a little easier to understand. So, oops, not unburnt area. We want to lerp it to the burn area. So we start off at green and then we burn into our red. Our red is burning in, right? So now we have a pretty clear distinction of what's happening. Our metals and our smoothness should still work. We can change these colors. So our base color can still be like, say, blue, and we're burning in, let's just say, this red color, like so. All right, so next, let's kind of create a bit of a searing effect, kind of like a burning effect, where the actual line is actually burning. So for that, we need two colors. We need two variables. One will be the emissive burning color, I guess we can call it, burning color. And what we also need is the thickness of that burn. So we'll take the burn cutoff, we'll duplicate this, burn thickness, I guess we'll call it. Go ahead and add the float here and the burning color here as well. In order to do that, let's kind of add it to the emission, because if we were to add emission here, it will actually blow it to white, right? So this kind of goes on top of the effect. This is how surface data calculates it. So all we really need to do is modify the emission. So let's go ahead and do that. The emission will be the unburnt area minus the unburnt area plus a little bit. So a little bit confusing, but we'll call it burning area. And this will add the emissive thickness, the burn thickness that we just created. So if we took this, which is the part that is above, right, subtracting the burn area, we should get the emissive thin line that we want. So we'll take the unburnt area and we'll subtract the burning area. That should create this, and this is our burn thickness, as you can see here. The burn cutoff line, we have that white line kind of leading it, right? And it burns into this red color, from this teal color into the red color. The burning color is this white, so all we got to do is multiply that by burning color, the emissive that is. And I think we do need to put brackets around the subtract. It's red, but let's go ahead and do green just so that we can kind of see everything pretty clearly. If this doesn't look very good because it's how pixelated it is, what I want to do is make sure that this texture is set up correctly. Texture is set to normal quality, set it to higher quality. Should kind of fix that up a bit. It makes it a little cleaner. 64-bit, I wonder if that's pushing it too much. Let's see. I mean, I think that looks pretty good. That smoothness, this texture probably is going to be extremely expensive now, but that does smoothen out things quite a bit. So I'll leave it at like that for now. All right, so the next thing I want to do is kind of work on the burnt area. Right now, as you can see, the burnt area is still very shiny. We want to get rid of the metallic and the smoothness when it comes to that burnt area. So a quick thing we can do is take the metallic and smoothness and just kind of subtract off the burnt area. And that should make it so that it looks like this, and we can probably darken it a bit. So now when it burns, it looks like it's not metallic, it's a little bit duller, which is good. However, what we also want to do is probably add a bit of a bump map. I want to add a normal map to the burnt area because it kind of looks a little bit charred, and we also want to add a little bit of a glow into that area. So let's quickly add a normal map, into it. I will briefly go over it again for those who don't actually know of it, but we'll just take the main texture, we'll duplicate this. If you know this stuff already, feel free to skip ahead. So we'll have a normal texture. Over here, sampler 2D, we'll add normal text. I probably won't do the scale and transition for this. I just don't think it's needed. So what we need to do is add the tangent here. So let's go ahead and do that. Call it tangent. This is tangent. Here we also need tangent and a bitangent. So we'll go ahead and create this. And we'll do text chord 5 and 6. We also need a strength of the normal. So we'll go ahead and take one of these and we will increase this range to maybe, I don't know, 5. And we'll call it normal intensity. All right, to set up our tangents, our normals material, our normal information, we'll start with the tangent, tangent. And we will take the vertex tangent that we get from the model. That's this one, right? V dot tangent. And we want to do transform object to world, right? We're just transforming the vertices, the directions of this V dot tangent. And we're only transforming the X, Y, and Z of this. And we will transform it to world. And here, O dot tangent is also X, Y, Z. I believe that's correct. We also want to transfer the W directly. So this thing disappeared, meaning there's this error. Turns out that I missed this tangent. Should be a float 4. Cool. Now the reason why we pass in the W directly, so tangents are just a direction, which is represented in X, Y, Z. However, the W is really to tell us which way the normal is facing so that we don't have accidental inverted normals. So we just always pass it directly from, we always assign the W directly from the vertex information, like so. Let's go back here. Great. Everything's back to normal. Next, we want the bitangent. The bitangent is always the cross product between the tangent, from the normals that we get in world space against the tangent in world space. So it's just simply cross. And I always do X, Y, Z just in case there are other values in the W against the tangent that's also in world space now. And we finally want to multiply it against the W. Great. Next, we can sample our normal map here. What we can do is just use Unity's unpack normal. So let's go ahead and do float 4 normals. It's equal to unpack normal. Yeah, unpack normal. And what we need to do is pass in a text 2D. So we can go ahead and take this, copy this, put it here. And after here, it's normal intensity. But let's go ahead and take the normal texture, drop it here. We'll use the same UVs and we'll have normal intensity here. Unpack normal scale. The scale gives us the ability to turn normal intensity. It doesn't like this, so we'll do unpack normals. Nope, my bad. It means normals is a float 3, not a float 4. Finally, we need to fix up the normals. Oops. So to do the final normals, what we need to do is take the unpack normals. We do the red channel first, which is the tangent, multiply it against the I dot tangent, plus green channel, multiply it against the bitangent. I think it's the bitangent next, yeah. Plus unpack normals, blue, multiply it against the normal, I dot normal. And that should be our final normals. Let's go ahead and take that and we will drop it into, as well as the normals in here. This looks really wrong right now. Oh, it's because there's no normal texture. Let's go ahead and put in a normal map. It's kind of, there we go. All right, so what we want to do is only have it affect the burn area. So what we can do is we'll move these to the top actually. Put it under here. And the burn cutoff also has to have the 1 minus up here. So we deal with the burn areas, then we have our normals. And what we can do is use the unburnt area against the normal intensity. My bad, other way around. And the normal intensity, if let's just say it was set to really high, what we need to do is not see. I see. I think it's because these normals are not normalized. So let's go ahead and normalize those. I set it to the bump to 0, and yet I still see bump. That's not normal. Okay, there we go. So now this can go back to normal intensity, and I will multiply it against the burned area. There we go. Now only the burnt area has normals. So this is a bit intense, so it can be something like this. This can be dealt to a really charry look, and you can kind of see that now it looks like the metal has been burnt into this kind of crisp-like effect. I have noticed that this red is really light. Let's go ahead and give it a little bit of a boost. Burning color intensity. And our burning color intensity needs to be multiplied against our emissive, so our burned area. So here, burning color intensity, we can crank that up a bit to give it a bit of a hotter glow, maybe something like that. The last thing I want to add is, when things burn, they don't always just kind of stay like this. They always have some sort of emissive burn after, some sort of hot color, I guess you can say. That's pretty simple to add. All we need to do is go to our emission and add on the burning effect. Like think of lava, they have glowy parts, right? So I want to add a bit of a glowy part to it. Let's go ahead and do that. Another burning color. So this is more like a searing color. So I'm going to rename this actually. Sorry for the extreme confusion here, but I'm going to call this searing color and leave this as burning color. So we'll add a searing color here. Searing color. Let's go back to here. It went to white because of the way it was defaulted to. I'll set it to yellow, but burning color will now be our burning color that is on our dark areas. Let's go ahead and add that. In my opinion, not everywhere will be burnt. So let's use our original texture, this one. Let's use the green channel to do our emissive. So let's go ahead and get color.green, right? And we'll multiply it against, not burning area, burn area. And then we'll multiply that against a new color, which was the burning color. That should be correct. And this is a plus. So this upper line is the sear, right? And this lower line would be the emissive that is on here. So as you can see, it did kind of work. It looks like it's using the green channel to create this other effect. To me, it doesn't look really good. The green channel may not be so good, but maybe in 1 minus of the green channel. This is a bit of a hack. Oops. Make sure to bracket it off. I just think it'll look a little better. You know what we need? We need a power effect. That's my guess. So a power, we will go ahead and add that here. So it's kind of a ramp and a multiply. So let's go ahead and create 2 more variables. Burn intensity, they're single values. Let's go ahead and add them here. And what we want to do is do the power function on here. We'll power up this, and then the ramp will be here. Burn ramp. And I'll show you in a second what it looks like. And this one we want to multiply against the burn intensity. That looks correct to me. So burn ramp and intensity. Okay, great. So the intensity is a bit high, but we need more on the ramp. So the ramp should not go to 1, it should go to 5 as well. So that should tighten up the look of it. We don't need such high intensity. Yeah, as you can see now, it kind of brightens up certain areas. I think the ramp has to be even higher. Let's go to 10. So we can, you see how we can, the higher it is, we can tighten up the look of it. And now the intensity becomes very easily tuned. So we don't have to use this color. We can use a color that has a bit more of a nice blend to it. We can do, let's just say, a reddish orangey burn. The searing color can be maybe, oh, I don't know, maybe like a cyan, as if it's kind of like electricity. And the base color can be, oh, I don't know, let's go with green, sure. And our cutoff is really the thing that's driving this whole thing. You can kind of now start to see how this kind of is working together. I think a little bit more intensity will look nicer, yeah. Yeah, and you know, with this kind of setup, you don't actually have to have the smoothness and metallic all the way up. It can be like a partially smooth metal that also has this type of effect. It's the burn cutoff that is driving it. Cool. Yeah, I hope this you guys learned something here. This is trying to utilize a lot of the searing effects that I've shown you how to do before, but I wanted to do it within URP, as well as, you know, take advantage of what they have set up here already, which is the surface data, as well. Actually, we didn't do too much of the input data, but really it's taking advantage of the emission that they've already pre-calculated for you, as well as some of the other setups that we have here, getting rid of the metal when it's being burnt. So yeah, have a play with this one and let me know what you guys think. That's it for me. Please like, subscribe, and follow my channel, and I'll see you guys next time. Bye now.